All right, so today what we're going to look at are some basic algebraic skills. Most of what we're doing here in this first week is looking at graphs, but we do have some basic algebraic skills that I want to make sure that you're familiar with. They're just some efficiencies that when we get to higher level math, we kind of need to be able to do that lower level math pretty quickly. So that's what we're looking at today. Here's one thing. It's the idea of squaring a binomial. Now, when we square a binomial, you may, in the past, and maybe still do, who knows, write this out twice, and then you do FOIL on it. So that would look like this. If I wrote x plus 5 and x plus 5, don't write this in your notes because we're going to change it here in a second. All right, so then if you FOIL it, first would get you x squared. Outer is 5x, inner is 5x, last is 25. What I want us to be able to do is to get from here to here with that. Well, actually not even there because I have like terms that I could combine. And I want to be able to get to this stage without having to do all of this FOIL. Because here's what happens every single time you square a binomial. You're going to end up with this value here being multiplied by itself. So this is squared. That's where this comes from. Same thing happens when you do lasts. You're always going to end up taking this number and squaring it. So we should be able to get that. Now, a lot of kids will go ahead and just do that. It's like they are distributing this, and they think you just get x squared plus 25. But you can see we don't. We have a middle term here that we can't ignore. That middle term comes from the outer and the inner. And since these are identical binomials, your outer and inner will always be the same thing. So how about if we just come way up here and we multiply these two together? There's your 5x, but you know it's there twice, so it's 10x. I think that's a simple enough concept that we could do that without having to write this all out in FOIL. So let's try it again. A little bit harder binomial, but the idea is that you're going to square the first term, so that's a 4x squared. And then to get your middle term, you multiply the 2, so that's going to be a negative 2x, but then you double it because it's going to be there twice. So it's going to be a minus 4x. And then to get your last, you just square that last term. It'll always be positive because when you square something, it's always going to go positive. Boom, there we go. All right, see if you can do this next one on your own. I'll wait a few moments for you to do that one. All right, hopefully you ended up with a 9x squared. Multiply the 2, get you a negative 12xy, but I have to double it, negative 24xy. Last term is going to be a plus 16y squared. There we go. All right, so there's a nice little efficiency that we will use often enough. Hopefully that will stick in your head. Some of you probably already do that. Okay, so then the next option here for an efficiency that we can work on is when I'm solving a quadratic. An option here might be to write this twice and FOIL it, or better yet, use our shortcut to do it. And then you'd subtract the 16 over and then refactor it. And that would work, except that we're looking at efficiencies. How about if instead we just get rid of this squared by square rooting both sides? When you square root both sides, the square and square root cancel out, and you just have your x plus 5. And then right here is what I referenced yesterday about when you put the square root there, you have to put a plus or minus square root of 16. So a plus or minus 4. This is a quadratic because it's a squared. And so I know I have to have two answers. If I don't do the plus or minus, I'm not going to get my two answers. Then you're going to subtract the 5. And you look at the two options. If 4 was positive and you subtracted 5, you'd get negative 1. If the 4 was a negative 4 and you subtracted the 5, you'd get a negative 9. And those are your two solutions. All right, so that's sort of a pretty straightforward one that everything came out nice. Let's look at one that maybe not everything comes out quite so perfectly. All right, so looking at this right here, I need to get this quantity isolated like it was over here. And so your first step is to get everything over here with the 7. Now, you do what you need to do here, but again, for efficiencies, I almost feel like probably most of us can go ahead and add the 3, that's a 10, and then know that you're going to come back and divide by 2, it's just going to turn that into a 5. So that's kind of doing a couple steps in your head. I like you to show your work, but some of that stuff you've been doing since Algebra 1, we can do that in our head. That's okay. And then we have this right here that's isolated like we wanted. Now you square root both sides, and you're going to have x minus 1 equals plus or minus the square root of 5. This one does not come out nice, so you just leave it as that radical. And then you're going to add 1 over. So I'm going to have x equals, I typically like to put that 1 in front, so it just looks like a 1 plus or minus root 5. And those are your two solutions. If you need it as a decimal, then you just got to go type it in your calculator. All right, what do you think? Can you do those? All right, so next we have factoring. And this one's a tricky one because every teacher teaches it differently. And in the end, I guess I feel like at pre-calc, we could probably use just some number sense. Number sense is a good skill. It's sort of like mental math ultimately, and it's being familiar with numbers and understanding how things are going to play out before you ever jump in and do it. And so rather than going through and doing the thing where you take the A times the B, or the thing where you split the 89 into 2, just using some number sense to understand how factoring works and being able to just put the numbers in where they go. All right, so I know that it's going to end up with 2 binomials. I know that this plus sign here means that my signs have to be the same. They're both going to be pluses. Well, so if that's the case, I could go ahead and just stick them in there if I want. But what that means to me is that my outer and my inner are going to have to add up to 89. That's a pretty big inside number. So my number sense tells me then that I've got to be multiplying some of the more extreme numbers somehow to build that up. So instead of using a 4 and 2, maybe I should be using the 8 and 1. So let's look at what that would look like, 8x and 1x. Now, I'm going to multiply this 8 times something over here. I need to build it up. It's going to be a factor of 90. I need to get it up big because I've got this 89 it's trying to reach. And you might be able to, I'm just kind of stalling here, be able to think through that in your head. Like if that was a 10 right there, that gets me up to 80 right off the bat. And factors of 90 would be 10 and 9. And look what you get there. Now you got a 9x and an 80x. There's your 89x. I feel like we could do that without having to go through a bunch of tricks or whatever with factoring. That's just number sense there. All right, let's try this next one. This one has a subtraction sign right here. This subtraction sign means that the signs will be different. And somehow or the other, I think in my head, okay, so if the signs are different, the outer and the inner have to have a difference of this 9 then. So when I'm building this up, the outer and the inner, one of them has to be bigger than 9 so that I can subtract and get it back down to the 9. Now, 9 for a middle term is not real extreme compared to the other numbers in there. So maybe I'm going to stick with my 3 and 3. If I did that, 3n and 3n. Factors of 24, I guess the first thing that jumps out at me is 4 and 7. I can put my 4 and 7 here. It doesn't really matter which one's where because they're both getting multiplied by a 3. But what you end up with is a 12n and a 21n, and those conveniently have a difference of 9. Now, I do want my 9n to be negative, so make the 21 negative, make the 12 positive, and you've got your factors right there. All right, next ones. I have just some little special ones. That's why they have a little red dot there. They're special in one way or another. In this one, what jumps out at me when I look at this is, oh, look, that's a perfect square and that's a perfect square. Sometimes what that means is that would break down to, or that would be called a perfect square trinomial, but it has to play out just right. But I'm going to jump in and give it a shot. What it means is just square root each of these and use those factors. So instead of doing 4 and 1, I'm doing 2 and 2. And I'm going to use 7 and 7. And if you'll notice, you get a 14 and a 14, which has a sum of 28. So we've got what we need. The signs are the same, but they're both going to be minuses in this case. And notice that those are identical. So what we might do is we might just go ahead and write it as 2x minus 7 squared. All right. The last one is one where the numbers are kind of big, but they have a GCF. You always want to look for a GCF because it makes your numbers smaller and the factoring goes much faster. So when I look at all of these numbers, I can see that a 4 goes into all of them. So I'm going to factor out that 4. And the 4 just stays out in front. And then I put in my factors. I can go 2 and 3, or I can go 6 and 1. Factors of 3 are just going to be 3 and 1. Let's look at what your signs are going to do. This means that the signs are different. And so you're going to want to end up with a difference when you do outer and inner of 7. I probably am just going to go with my 3 and 2. And again, kind of stalling here. I'm hoping that some of you can kind of think through in your head, all right, if I put a 3 there, that's going to be a 9. And, oh, it's a 9 and a 2. That's what I want. I want that to have a difference of 7. I do want it to be a positive 7, so I want my 9 to be positive, and I want my 2 to be negative. And that is your factored version. All right, so just trying to encourage you to use a little mental math on these problems. All right, as I said, we're just going to kind of hit on some efficiencies and just some kind of random topics in all honesty. Okay, so here we're talking about domain. We deal a lot with domains. On our first day when we did our toolkit, we were doing the domains, and algebraically, when you look at domains, you're looking at a couple situations. Many times your domain is just all real numbers, anything you want. But there's 2 scenarios that you have to be careful on, and it's fractions because you do not want your denominator to be 0, and radicals because you don't want to end up with a negative inside there because that would be imaginary. All right, the domain of a function can be described explicitly, which means you are setting a rule, or it can be implied. Sometimes if we're doing just a whole bunch of problems, we might just say that the implied domain is this. We'll just assume you can never have 0 in your denominator kind of thing. Or there's just it's kind of like common sense kind of domain. All right, so let's start with doing an explicit. We're going to come up with a rule. In general here, x squared minus 4 cannot be 0. So you're looking at what would make it be 0. So I put a not equal to here, but ultimately you're saying what would make it equal 0. Now there's a couple ways you can do this. You could do the square root property because you could add the 4 over and square root both sides. It also happens to be a difference of squares, so it could factor to x plus 2, x minus 2. Either way you choose to do it, you're going to get 2 solutions of 2 and negative 2. But remember that that's what x cannot be a plus or minus 2. Now, if you write it like that, that's one way, but it does specify that we want this in interval notation, it says. Write it in interval notation. Okay, so interval notation means that you go all the way, what's the farthest left number that would work? So it can go from negative infinity up until you get to negative 2. It cannot be a negative 2, so we put a parenthesis. In union with, now I pick right back up at negative 2. And then it goes to positive 2. It can be all the way to positive 2. But it can't be a 2, so I got to put a break in there. In union with, and then you go from 2 to infinity. All right, that's how you would do this in interval notation. It's a little lengthier setup, so sometimes we're lenient and we let you use just the x cannot be plus or minus 2. Either way is acceptable. Unless you're in my math lab homework and they specify how they want it, or if I specify how I want it. And I did. I said interval notation. Okay, so let's move on. Square root. You cannot let that be negative. So instead of thinking what it can or can't be, I usually will take this radicand, that's called the radicand, that number in there, and I just say that that has to be greater than or equal to 0. Now, this one's pretty straightforward because it's just an x, but as that gets fancier, what's inside there, then I might have to go solve this inequality. But ultimately, this is the mentality that we use. It has to be greater than or equal to 0, which in interval notation means it can be 0 and anything bigger than that. Okay, take a minute right now and go ahead and pause the video, and you try these next two on your own. I'm not going to wait forever, so make sure you pause. All right, let's do a quick overview of these two. This first one, the volume of a sphere, this is not a fraction. The R is not a fraction. The 4/3 is, but that's just a number. It's not a radical. So in your mind, you might think, I think that could be anything I want, except that common sense implied would be that your radius of a sphere cannot be negative. It can't be 0, or you would not have a sphere. So your domain should be using the common sense implied domain that your R value has to fall somewhere from 0 to infinity. Cannot equal 0, so you have a parenthesis on there. Okay, this next one is the radical issue. So I want to make sure that 4 minus 3x is greater than or equal to 0. You can solve this different ways. I'm going to subtract the 4. I'm going to divide by -3. Remember, when you divide by a negative, you switch your inequality. And so you're left with this right here. That's an inequality notation. In interval notation, it says x is less than that. So I'd say from -infinity would be the smallest all the way until it gets to 4/3. It can actually equal 4/3. So I do a bracket on that one. Now, in pre-calc, we also will try to start using function notation more. And so I wanted to kind of just practice how that looks. Instead of a y, you can use an f of x, or in this case, a g of x. And if you wanted to plug a value in for x, maybe we'd say, well, x is equal to 2. But another way to write that is just find g of 2. So to find g of 2, all that's saying is go ahead and put this 2 in place of the x. And so you put 2 in all of the x's there. Remember, order of operations, when you put in a 2 in this first term, you're going to square it first and then make it negative. So that will end up being a -4. Put 2 in the second x value, and you get a +8, and then a +1. And in the end, g of 2 is equal to 5. We will get a little bit more algebraic. So instead of putting a number in, maybe you're just putting a variable in. In this case, I'm doing g of t. Ultimately, that just changes all the x's into t's. But what I'm really leading into here is the next one. And the next one is when I'm trying to put a quantity in for x. So every place I see an x, I'm going to put in an x plus 2. So that's going to look like this. We'll do this when we get to the calculus part of pre-calculus. All right, so now we're just going to kind of clean it up. Let's use our new shortcut to square this binomial. So I'm going to do a couple things here, just trying to be efficient. I'm going to use our shortcut to square this binomial, but then I'm going to make every term the opposite sign because of the negative that's in front of it. All right, so my first term would be x squared, but I'm going to write -x squared. Multiply the 2 and double it, so that's going to be a 4x minus 4x. Square the last term, that's 4. Got -4. Now I'm just going to distribute the 4 through the binomial there. All right, and so now let's look at any like terms we can combine. Looks like our 4x's are going to cancel out on this here. And I'm left with a -x squared. And that's going to get me a +5. Okay, so just being able to plug values into a function is what we're working on there. And now our last thing for this lesson is going to be to evaluate piecewise functions. We will do a kind of a whole activity on piecewise functions and a nice application of them. But let's just understand in general what they are. It means just you're using pieces of functions, and which piece of the function you use is always dictated by some sort of inequality out here at the end. So in this case, they're saying that, hey, let's use this function right here. This is a nice quadratic function. We should know that that's a parabola. There's your x squared. Hopefully you also remember that a plus 1 just takes your parabola and moves it up 1. Okay, we haven't done that yet. We'll do it here this week. But here's my parabola that's moved up 1. But I'm only using a piece of that parabola. I'm using the piece when x is less than 0. So from the x equals 0 mark, I'm only using the left part of that. This second part says, hey, let's use this linear function. This is just a linear function. Slope is 1. Y-intercept is -1. And we're going to use that line, which you can see is right here. And we're going to use that anytime x is greater than or equal to 0. So then you see it here. This is what the graph of one looks like. And we will do a little bit of that as well. Sometimes the two pieces actually merge onto the same spot. In this case, they don't. They sort of jump from one to the next. Now, to evaluate on a piecewise function, it just means you're going to take this x value, whatever that is, and you're going to plug it in. You don't plug it into both. You plug it into the appropriate one based on the value of x. X is -1. That would fall into this category where x is less than 0. So then what I would say is, all right, well, f of -1, remember, that's just our nice function notation, would be, and I'm going to plug -1 into the top function. That'd be -1 squared. That's 1 plus 1. All right, and we're just going to do all three of them. So now let's find f of 0. So you have to identify where 0 falls in the inequalities, and that would be because of the or equal to, it's going to be in this one. So I'm going to plug 0 in for x right here, and 0 minus 1 is -1. And then our last one to find f of 1. Again, going to fall into the bottom category there. So if I put it into that linear function, 1 minus 1 is 0. Okay, so that's sort of it for today. That's just a lot of little things that we do algebraically, just trying to refresh our memory on some and maybe get efficient with some. Hope this helps. Bye.